Hi. So today we'll discuss about our project, which is the power dissipation calculation for prediction of the BJT. So here we designed a circuit. A BJT is shown, which is having in common emitter configuration. Some stimulus is given here. So let's run this. So for power dissipation, we need the current at the collector and the voltage between the collector and emitter. So let us rearrange this. So let us read the current at the output. So this is some such looking like this. So you can see we have to take some points on the table to take us a data set. So let us take some points and left clicking will go to the view, then to mark data points. So as you can see that some of the data points are marked, so we'll just export them as a text file. Okay, we'll export the data as text. So we'll export them. We are exporting IC of Q1. The Q1 is the transistor name. So we'll export them to, let us make it BJT power and making it, renaming it as BJT text. Okay, we'll put OK here. So now moving on to the program. Okay, this is a basic program of predicting the power of BJT. So I have imported NumPy as NP, Pandas as PD. These are some kind of nicknames, so you can recall them as a by short name. So as done here, you can see that the PD is recalled. When PD is written, it will automatically find it. Panda library is calling. Okay, so after the TensorFlow, SDF, and then Keras, and then train test split to obviously split the data. Pandas is basically used to manipulate the data, which is basically best in, or we can say good in the handling the tabular kind of data, as we have the table kind of data. So let us see the data. Okay, so this kind of data we have from the BJT. Okay, so put in the Excel sheet and format that, convert into another format, which is like, it is in exponential form, like convert into the points form like 1.23 or etc. Okay, moving further, uh, this is standard scaler for, like, to scale the input, like will equalizing the variables, like uh, if we not perform like this, so there is lot lack of fairness, something like two variables are different like unit. If you do some variables at different units, then they are not equal, so we are equalizing them in that way. So at the land we have imported the mean square error. So mean square error is just calculate the mean square error between the predicted and the actual target. So here we imported our file by this command from to google.colab import files. Okay, so let me just run it and I'll show you how to upload this. Choose file. Okay, just we have put this file in the music, BJT power and input data. Okay, this is the file. So after this file is going to upload, as you can say, the input, this is saving the input file and 100% done. So after that, given a data variable, calling the Panda library PD, reading the file CSV. This is the name of the file. This is just to read the CSV file. Okay, now this is our file. This command data head will show some of the rows columns of that, like columns are only 3, but the rows are like 20 to 20, 30 something. So this command will just print few of them. So let us show this command work. So if I remove this command, this will just going to predict the some unnamed like columns. So for now I am just deleting that unknown column, so which is nan. So it will delete and show us. Okay, further just printed the data and columns, like what are in the columns, like VCE column is there, IC1 column is the power dissipation, and further. So it is just to line next command is just to print the data which is in VCE column. It will show some of the value, not some of the, it will show all of the values which are in the VCE column. So that kind of. So I think should we relate this. So further just giving the data which is VCE values and ICQ1 values to the X and Y to the power dissipation values, just creating an array. So further explanation is like we'll split the data, we'll scale, we'll put this data to the model, compile it, fed the model, test the accuracy or we can say loss, and further predict the values. And further explanation is given by the Pankaj. So thank you.